Hi, and welcome back to the Function Junction podcast. Previously, you did an intro known as secret codes. Secret codes gave you an insight to what a function actually looks like. So today, what we're going to do is we're going to figure out what is the difference. We need to know what exactly is a function in relation to a relation. So this is what we're going to learn today. What is a relation? Well, right here we can see that a relation is a set of ordered pairs. So any set of ordered pairs shown below as 1 is known as a relation. It can be 2 ordered pairs, or it can be infinity of ordered pairs, but any set of ordered pairs is a relation. So that's our first definition. We also can represent a relation in multiple ways. We can model it in an ordered pair, which is what you see above, a table, mapping, and graphing. We will see these 3 in a moment. So now we know what a relation is. It is a set of ordered pairs. Important words to know before we go along. We have our set of ordered pairs. Now, we know that each ordered pair, from previous knowledge, we know that the first letter is our X, and the second number is our Y. Okay? Now, when it comes to relations and functions, we have a domain and a range. Those are our 2 newest vocab words. A domain is the X coordinates of the relation, whereas the range is the Y coordinates. So I'm going to go through my set of ordered pairs that they gave me, and I'm going to highlight all my domains and all my ranges. So I have 1, 3, 5, and 7. Those are all my X values, which makes that my domain. So I'm going to go ahead and write that out. We have 1, 3, 5, and 7. That is my domain. Then we go back through. We need to highlight all our Y values, or our Y coordinates. That I've done in blue. Now this is our range. So we're going to go back through, and we're going to do 3, 5, 7, and 9. Now that is our range. So the domain and the range is a set of coordinates that come from your ordered pairs. These are going to be important to remember as we go along. So what exactly is a function? Well, we're going to learn. A function is a relation, okay? A function is just a special type of relation. So what makes it special? A function that is a special type only has one range per domain. So what does that really mean? Let's think about it. It only has one range. Well, we know our ranges are our what values? Remember, it's our Y values. And our domains are our what values? Those are our X values. So another way to say this is a function is just a special type of relation, meaning it's going to be a set of ordered pairs, but it's only going to have one Y per X, okay? Meaning none of our X's can repeat. Let me go ahead and write that down so we can note that. Those cannot repeat. Now don't get it confused, because we can have as many Y's as we need, but our X's cannot repeat. So let's look down here at the bottom. This is an example of a mapping. We're going to learn about this in a minute. This is another way to represent a relation or a function. Okay? What you see here is on the left side we have our domain, and on the right side we have our range. So we have our X values here and our Y values here. what you do is you put them in order from least to greatest, and then you're going to connect every domain, every x, to a corresponding y. So we see right here 1 and 3 go together. So we've put a 1 and we've put a 3, and they've drawn a line that connects it. In our next value, we see 3 and 5. So we go 3 to 5. And it keeps going. In this instance, the lines connect straight across. It will not always happen like this, but in this case, it does. And since we only have one, our x value of 1 only goes to 3, the x value of 3 only goes to 5, the x value of 5 only goes to 7, and the x value of 7 only goes to 9, these only repeat one time. Therefore, we can consider this a function. Getting the hang of it? Let's try some more. Another way to represent a relation or a function is through a table. What you see here is a table below. You have all your x values and you have all your y values. Now, we know from previous math that we need to put them in order through our table, correct? They need to correspond. So all my x's are going to be blue, and all my y's are going to be green. We're going to plug them in. We've got 3, 5, 7, 9. We've got 1, 3, 5, and 7. Now if we look right here, none of those x's repeat, do they? We only have 1, 1, 1, 3, 1, 5, and 1, 7. These are the same ordered pairs as last time. Therefore, we already know it's a function, but this is just another way to model that we indeed do have a function. This is through a table. Mapping. This is what we just did in mapping. Since we've already done this set of ordered pairs, I'm going to alter them, and I'm going to show you another way. Let's go ahead and use these numbers, and let's add 1, 1, and 5, 2. Oops, we can barely see that 2. Let's put a 2. Okay, so we're going to go through. And again, you're going to get all your x's. I'm going to go ahead and highlight. 1, 3, 5, 7, 1, and 5. And then 3, 5, 7, 9, 1, and 2. Okay? We need to plug that in. That's our range. This is our domain. Domain and range. Let's plug it in. We have a 1, mark it out. 3, mark it out. 5, 7, and then we're back to a 1. But since we already have a 1 in our table right here, we don't have to repeat that. Okay? So since you already have your 1, you do not need to repeat this one. So we can just go ahead and mark it out. Same thing with the 5. You see we already have a 5 right here. Therefore, we don't need to repeat that 5 either. We can go ahead and mark it out. You'll see why in a moment. Now let's go to our ranges, our y coordinates. We have a 3, a 5, a 7, a 9, a 1, and a 2. You see I put them in order, okay? Now we've listed it. You must draw your lines. I'm going to do my lines in red, but it has to be to the corresponding coordinate. So when we look at 1, our 1 responds to 3. So we need to draw a line across to that. 1 goes to 3. And then right here we have 3 that goes to 5, 5 that goes to 7, and 7 that goes to 9. So far we have one x coordinate for every y coordinate. But then when we get here, we go from 1 again, and 1 shares this 1. And then 5 shares this 2. Now look here. Do we see how 2 lines are going from this 1 and 2 lines are going from that 5? That really means we have 2 coordinates. We have this coordinate and this coordinate that repeat, and that coordinate and that coordinate repeats. Since we have those coordinates, this is not a function. We just know this as a relation. Okay? It's not that hard. You just have to know your definitions. So let's keep those words in mind. The very last way to graph it, or to model it, is to graph it. Okay? So what you're going to do, we all know that this is our x-axis and this is our y-axis. And that we go across on the x-axis first and then up and down on the y-axis. So let's plot our first point. We have 1, 3. So I need to go over 1, up 3. I need to go over 3, up 5, over 5, up 7, and over 7, up 9. You see here I've graphed all my points. And that is how you graph a relation. In a moment, you're going to learn how to tell if this is a function or not. But for right now, it looks like we have a pretty linear line, which is something you're going to learn about in the units to come. Okay? So, we're going to look here on the screen. These are all our different ways of how to model a relation. We have an ordered pair, which is what a relation is. We can take this set of ordered pairs and put it through a graph, put it through a table, or put it through a mapping. But no matter which way we put it to, it all gives us the same information. So that is the good thing about functions, is you can model it whichever way you are comfortable with, and it's going to give you the same information. So let's try. Here I've given you a set of ordered pairs. I want you to go ahead and put this set of ordered pairs into a table and into a mapping, and let's see what we come out with. I'm going to go ahead and give you a couple seconds. Keep in mind, it's easier, especially when we're beginners, to highlight or color or circle the domains and the ranges so we don't get mixed up. Okay? And then let's go ahead and fill in. Keep in mind we must go in order. So we have to go from least to greatest. So I'm going to go through all my yellows, all my x coordinates that make up my domain, and find the lowest value. I have 3, 4, -3 is the lowest. So I'm going to go ahead and put that in first. Then we have 3. Then I have 4. And then I have 9. I've listed all my x coordinates. Here's my domain. Now let's go for my range. We start with -2. Don't get mixed up with 2 being bigger than 1, because keep our integer rules in mind. Okay? View your number line in your head if you have to. -1, 0, and 2. Alright, sorry, we had a little bit of difficulties there, but I'm back. Alright, so what we're going to do is you're going to draw a vertical line. And when you draw your vertical line, like I've done so, it cannot pass through one point. So you want to draw a vertical line through every point. And we can see here it only passes through at this one point. If we draw it again, it passes through one point. Here it only passes through one point. When we get over here to this data, we can see that it passes through point -1, 2, and point -1, -2. This means that we do not have a function. We can see here that we have two of the same x values. We have two of the same inputs, and that can't happen. Therefore, this is not a function. Okay? That is the vertical line test. If you go onto your SMORE, there is an interactive vertical line practice test that you can play around with, and it lets you draw your own lines and find functions versus relations. Now it's your turn. Let's see how much you've mastered in functions. What you're going to do is you're going to log on to your Function Junction Scoop-It, and Learning with Functions Domain and Range worksheet will be seen. This gives you a short 5 problems that you're going to do with your partner, and then we're going to come back together as a class and check our work. Okay? Use this video for guidance if needed.